Hello viewers, hope you are doing good. So up to the previous one, we discussed about machine learning, types of machine learnings. So first, what do you mean by machine learning? It is subset of the artificial intelligence. It is mainly used to find out the future predictions with the help of existing data. Just act like a human thinking. So here three different types of machine learnings are there: supervised, unsupervised, reinforcement. So in the supervised, again it is divided into two types. The first one is regression, then the second one is classifications. So in the previous video we discussed a lot about regression. In that with the help of Python program we discussed about the linear regression. So here we are going to discuss about one of the classification algorithm, KNN, K nearest neighborhood. It is one type of classification algorithm. So it is also used for regressions. So for example, if you are going to check whether the incoming mail is sperm or not, we may use the KNN algorithm. At the same time, with the help of existing data, just like if you are going to find out the rent of current house, with the help of the previous one we can able to decide it. So that is comes under the regression. So KNN is used for both regression and classifications algorithm. So here for your understanding I just given the example of classifications. So before entering into the session, first you must be clear what do you mean by KNN. So it is the expansion for KNN is K nearest neighborhood. It is one of the simplest supervised learning algorithm because it is only applicable for small data set. So before that, what do you mean by supervised learning? So if you are going to train the machine with the help of labeled class, so that is called as the supervised learning. What do you mean by labeled class means if your data set consists the collections of conditional features and the decision features. That is decision feature is called as a labeled. So if your data set is labeled one, you may use the classifications algorithm. So with the help of certain point, I am going to classify whether the new data set is fall in which category. So that is the main target of KNN. So here K represents the size of the nearest values. So depends that only I am going to predict. So we just now we discussed KNN is applicable for both classifications and regression. So what do you mean by regression means if your table consists here continuous values. For example, with the help of experience I am going to find out the salary means it may consist different types of values. So that is called as the continuous values. Classification means if your table consists only discrete values. For example, Boolean values like yes or no. Otherwise set of values are there. Male, female. Yes, that patient is affected by the disease, whether it is yes or not. Formal, informal, like that. So that type of data set is accessed with the help of classifications. So KNN is applicable for both classification and regression. So in the classification, the real case example is going to check whether the incoming mail is a sperm or not. Then in the regression, I am going to predict the current house rent with the help of the existing values. So these are the two examples for your understanding. Why KNN means this is the simplest algorithm. Out of n number of classification algorithms are there. Out of that, this is one of the simplest algorithm for beginners. It is flexible for both classification and regression. Some of the algorithms are only suitable for the regression problem. Some of the algorithms are only suitable for classification. But KNN is used for both classification and regression. That's why it is called as flexible one. Here, no need to train your machine. So here you just directly use the KNN algorithm for feature predictions. Other than KNN, we have to train the machine with the help of training data set. After that, use the test data set to identify whether machine is currently predicted or not. But that case is no need here. So that's why it is called as the no training required. Directly you can apply the KNN for your predictions. But what's the main drawback here means it is only applicable for small set of data. If your data set consists of small records, it gives the accurate value. Otherwise, it may be comes in the overfitting or underfitting. So what do you mean by overfitting means your algorithm is working good in the training data set, but it does not work in the testing. It is not able to predict the testing values. So that is called as the overfitting. Underfitting means your algorithm is not fit for both training and the test samples. So that is called as underfitting. So KNN is only applicable for small set of data.